Okay, so this is a lesson, an introductory lesson on sequences and series. So everyone needs to take really good notes. The whole purpose of flipping this is that this is a big note-taking thing, and it's silly for you to just spend a whole period taking notes. So tomorrow when you come in, you are expected to have these. So here we go. Definitions. A sequence is a list of numbers where each number is called a term. A series is the sum of a sequence, or the sum of a list of numbers. Something that is arithmetic in nature has a constant addition or subtraction pattern. Okay, and we call that addition or subtraction pattern the common difference. And by that, I mean it's like plus 2, plus 2, plus 2. It's not going to be like plus 1, plus 2, plus 3, plus 4, plus 5. That's not, even though that's a pattern, it's not the same every single time. Something that is geometric has a constant ratio. And that ratio is a multiplication pattern. Now I want you to notice I didn't say multiplication or division pattern. If it's a division pattern by 2, we're going to multiply by 1/2. It's still going to be considered a multiplication pattern. Right. Something that is an explicit rule is an equation that gives any term in one step. Something that is a recursive rule gives terms based on the previous term. All right, so now we have a number of symbols. Oop, I don't know why that equal sign is there. All right, we have a sub 1. It's not a1, it's a sub 1. And that is going to equal the first term. We have a sub n. Not an, a sub n, because it is a subscript. It will be below the line, like a log base. And a sub n is going to be the nth term, because if it was a sub 2, that would be the second term. Okay, and then we have a sub n minus 1, and that is considered the previous term. Okay, so there we go. So then we have a set of formulas here, and you see I've made some notes. I'm going to erase some of them though. We have our sequences and series formulas, and we have, oh wait, actually, undo that. There we go. All right, so we have a sub n, so to find any term, we would take the first term plus n minus 1 times d. D is the common difference. So if you think about it, if we have a sequence, and we want to find the 5th term, for example, we would take the first term plus 4 common differences, 5 minus 1. Now, to find the sum of any terms, we can use this nifty little formula, n times the first term plus the last term over 2. Now, you'll notice there are 2 formulas here. The first formula is handy if I know the first term and the last term. The second formula is handy if I don't know the last term. And I want to point out that this second formula comes from, I've got it handwritten down here, just plugging in the formula for the nth term into a sub n. So you can see I've kind of just filled it in, and then a1 plus a1 gives us 2a1. And then we have the formula for the geometric sequence and series, and you might want to make just a little note here. There's my pen. That, you know, R is your common ratio, and D is the common difference. All right, so what we're going to do is we're going to take a look at writing the rule for the nth term and then using that rule. So here we go. And you have this in your packet, I think. So it says write the rule for the nth term of the sequence and find a sub 15. So the first thing I notice for number 5 is that it's a subtraction pattern, and the common difference here is -5. And the first term is 12. So to find the nth term, I would take 12 plus n minus 1 times -5. Because every term after the first term, I would need to subtract 5. So there's my equation. And now to find the 15th term, I'll take 12 plus, well, what's 15 minus 1? 14 times -5. Grab my handy dandy calculator, and I get -58. Now, I just want to take a second and point out that over here, you can distribute this, -5, and then it starts to look like y equals mx plus b, because we have 12 minus 5n plus 5, which would become -5n plus 17. So like that would be your slope and your y-intercept. So here we go. Number 6, there's our first term. We can tell that we are adding by 4. So a sub n is going to be 19 plus n minus 1 times 4. I'm actually going to do this. I'm going to distribute the 4. You need to do this also. And so the formula for the nth term is going to be 4n plus 15. And so then if we do the 15th term, and you could plug it back in here or here, whatever one makes you happy. You could do 4 times 15 plus 15 is going to give us 75. So what I want you to do is I want you to take a look at the next problem, and I want you to just try that real quick on your own, getting the formula for the nth term and then evaluating. And then we'll move on. We're not doing all these. Okay, so for the explicit rule for number 7, a sub 1 is 5, d is 2. So, whoa, oh, poopy. So let's see. A sub n is going to equal 5 plus n minus 1 times 2. Distribute the 2. Combine like terms. And we get 2n plus 3. Box. And then a sub 15 will equal 2 times 15 plus 3 will give us 33. And at that point, honestly, you should be good at explicit formulas for an arithmetic sequence, noticing something has an addition or subtraction pattern, and writing the formula that gives you any term in one step. So let's take a look at finding the sum of these sequences, finding the series. So it says find the sum of the first n terms of the arithmetic series. So I know that I'm looking for the sum of the first 19 terms, and I know that the first term is 2. So I'm going to make a little note. A sub 1 is 2. I can tell from the addition pattern that the common difference is 1. I do not have a sub 19. If I had a sub 19, I could use the first formula. But because I don't, I need to use this formula. Bam, this guy right here. Because I don't know what a sub 19 is. Now, I could go and find it off to the side. That's totally your prerogative. But I'm lazy, not doing it. All right, so here we go. I'm looking for the sum of 19 terms. And I will do this by saying 19n 2 times a1 plus n minus 1 times d all over 2. All right, so we've got 19, and then this becomes 4 plus, that becomes 18 times 1 is 18 over 2. 4 plus 18 is 22. 22 divided by 2 is 11. And then you can grab a calculator if you like, and 19 times 11 is 209. Okay, so what I want you to do is actually use the same formula, and I want you to try number 12 on your own. All right, so for number 12, again, this is A1. We can tell that D is 10, and we are looking for the sum of 50 terms. The sum of 50 terms is going to be 50, 2 times the first term, plus n minus 1 times D, all over 2. You just want to be careful because there's a lot of arithmetic going on here, and it's okay to use your calculator, but the beginning should be done in your head. So we have, this gives us 50. This is 49. 49 times 10 is 490. 490 plus 50 is 540 over 2 would be 250, 60, 70. 270 times 50, grab a calculator, is going to be 13,500. So if you got 13,500, rock on. Let's look at some geometric series. All right, so we're just going to start by writing some rules. These should go pretty fast. First thing I'm going to notice for number 1 is that it is a multiplication pattern by 3. So to find any term, I need to start with the first term times 3, and I'll raise that to the power of n minus 1. That's it. For number 2, I see the first term is 1, and the multiplication pattern is times 6 raised to the power of n minus 1. Why don't you take a second and do 2 and 3, or 3 and 4. Okay, so for number 3, we should get a sub n is 2 times negative 3 raised to n minus 1. And for number 4, we have a sub n is equal to 7 times 2 raised to n minus 1. So now it says find the sum of the first n terms in the geometric series. So take a look at your notes, and we're going to just really follow that formula and use our calculator to help us. The sum of 12 terms is equal to the first term times 1 minus the ratio, which is 4, to the power of n, all divided by 1 minus r. Now I'm going to put this in parentheses because if you type this into your calculator all in one step and you don't have it in parentheses, it's going to be super sad and depressing because you're going to get the wrong answer. But everyone grab your calculator. Remember, you can always pause the video if I'm going too fast, and you should get quite a large number because we are adding up a multiplication pattern. 11 million. Woo! Okay, so everyone try number 9. So the sum of 9 terms should be 1. And then we've got 1 minus negative 6 to the power of 9, all divided by, well, honestly, guys, I know that 1 minus negative 6 is 7. So when I grab my calculator, I just type that in as 7. That's just me. Hey, if you can't, don't tell me. Now, before we turn the page, I just want to take a look at something. This is not hard, but there are a lot of situations that can lead you to math jail, and this is right here probably the biggest one. Everyone go back to this before we go on, I want to point this out. You cannot reduce this at all. You cannot make this 14 to the n minus 1. Order of operations tells me I need to do the exponent before I can multiply. If I see this on your paper at any point in time, it will be automatic math jail, and you will lose full credit on the problem. Okay, so the last thing we're going to do is we're going to take a look at some recursive rules. So here we go. We're going to write recursive rules for these sequences. Now, before we write the recursive rules, we're going to identify a couple things. First off, it's obvious what the first term is. That's kind of a duh moment. The next thing I want to notice is what kind of sequences are these? Well, number 1 appears to be arithmetic, and I have a D value equal to 5 because I'm adding 5 each time. Number 2 appears to be geometric, and I am multiplying by negative 2 each time, so that's my ratio. When we write a recursive rule, we must have 2 parts. A recursive rule gives us a starting value, so a1 is 2, and then it says to find any subsequent term, a sub n, take the previous term, and the way we say previous term is n minus 1, and add 5 to it. So for example, just to go through this notation, if I was looking for the 1, 2, 3, 4, 5, let's say we were looking for the 6th term. Common sense, people, what is it? That's right, it's 27. You just used a recursive rule, congratulations. So if we were looking for the 6th rule, we would need to take the previous term, so the 5th term, and add 5. And that's what we did in our head. We did 22 plus 5, and that was 27. That's how a recursive rule works. It just continues the pattern. So for number 2, we need to say start with 4. Then to find any other term, take the previous term and multiply by -2. Cool. You could also write this as -2. Either one's fine. All right, so what we now have are a couple recursive rules, and we're going to follow them. So here we go. It says write the first 5 terms in the sequence, and we've got the first term is 10. And then to find every other term, we're going to take the previous term and subtract 2. So here we go. 10, previous term minus 2, previous term minus 2, previous term minus 2. 4 is now my previous term, minus 2 is 2. Okay, we're going to skip number 2 for now because it's tricky, Mickey. So number 3 says start with 3 and then previous term plus 2. So previous term plus 2, previous term plus 2, previous term plus 2, previous term plus 2. Everyone try number 4 on your own. Okay, so for number 4, first term is 1. This says 2 times the previous term. So 1 times 2, so now this is my previous term, times 2, times 2, times 2. All right, so now we are being asked to write some recursive rules, and this is going to be the last thing we're going to do. No, I'm a big liar. We're going to do a few of these. We're going to do them selectively. So I'm going to do one from each group, and then you're going to do one from each group. So it says, write the recursive rule for the arithmetic sequence. Now, the funny thing is you have to give a starting point. So here we go. First term is 2, and then to find any other term, we're going to say, take the previous term and add 4. The reason I know to add 4 is that it's a common difference. It didn't even need to say arithmetic sequence. I see the D, I know to add. So number 9 says first term is 3. To find the next term, we're going to take the previous term and multiply by 8. So now 13 is, look, I'll be a little careful, people. 1, 2, 4, 8. Oh, it's a times 2. It's geometric. First term is 1. Any following term will be found by taking the previous term and multiplying by 2. So right now, I want everyone to do 7 and 11. Hit it. Okay. Number 7 should be first term is -3. And to find any other term, we would do the previous term plus 1. For number 11, it's geometric. The first term is -2. To find any subsequent term, we would do 0.3 times the previous term. I don't like 14 because it's not arithmetic or geometric, and we're not doing the ones that aren't arithmetic or geometric. So now what I would like you to do is take a look at 15 and 16, and we'll call it a video. Go. Pause the video if you have to. Okay, so for number 15, hopefully we all wrote down that the first term is -12. That's easy peasy. We're just going to ignore that bell. Pretend you're not in class. Well, actually, you're not in class, so it's not really pretending. And now, every term after this, I see is subtracting by 4. So I'm going to say previous term minus 4. And then for number 16, I see the pattern is multiplying by -3. So I'm going to say -3 times the previous term. I'm not putting the -3 at the end because I don't want to look like -3. That would be bad. All right, ladies and gentlemen, you have quite a bit of homework tonight. Take a look at your schedule. You have some worksheets in the packet. Please follow the directions carefully or suffer the wrath. You are doing, I'm going to write it down here again. You are doing numbers 1 to 12. And then you have a special note on 7 to 12. You are to write both explicit and recursive rules. And then you are also to do number 29 on that page. And then on 11.3a, similar directions, you are to do numbers 1 to 15. And on 10 to 15, again, write both explicit and recursive rules. And you are also to do number 30.